The Explorer, one shuttle, NASA's utmost voyaging shuttle ever sent off, continues its stunning excursion over the universe. For nearly 50 years, Explorer 1 has been returning crucial messages and data from the farthest reaches of the universe, essentially propelling our comprehension of the cosmos. However, recent messages sent by this amazing rocket have introduced ambiguous signs that have put everyone in the space community in a state of wonderment and bewilderment. These signs have sparked debates about whether they are the consequence of a technical error or the possibility of a clear indication of something extraordinary, for example, extraterrestrial activity. Join us as we dive deeper into the mystery surrounding these exceptional transmissions and uncover what may be prowling in the depths of space. Humanity's interest in the secrets beyond our planet has been a main motivation for space exploration, ever since its beginning. This fervent curiosity prompted the historic mission launch of Voyager 1 and Voyager 2, which were among the most aggressive space attempts made during their time. The start of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977, marked the beginning of a new era in space exploration. Only 14 days later, on September 5th, Voyager 1 followed, making way for a remarkable journey. These twin shuttles, each weighing around 720 kilos, generally comparable to a small vehicle, were introduced during a singular synchronization of the outer planets that played a significant role in their trajectories and outcomes of the mission. Throughout their striking odyssey, these spacecraft traveled in disparate directions and at different rates. A crucial moment occurred on December 15, 1977, when Voyager 1 beat its twin due to differences in their paths. Since then, Voyager 1 has emerged as an imperative resource, providing significant data that has transformed our understanding of the universe and its numerous previous phenomena. Delve into Voyager 1's most recent surprising discovery, which has captured the attention of the entire space community and ought to be revisited in some of its most exceptional accomplishments. In 1978, during its Jovian imaging mission, Voyager 1 was situated about 265 million kilometers away from the planet. By January 1979, it had begun a remarkable 100-hour workday mission, capturing a captivating time-lapse film of Jupiter's rotation. This series of 3,650 pictures offered remarkable perspectives of Jupiter's dynamic atmosphere and its complex features. The spacecraft's discoveries included the revelation of a small ring around Jupiter and 2 previously unknown moons, significantly expanding our comprehension of the gas giant's intricate system. To ensure the spacecraft's safe passage and avoid potential impacts with Titan, one of Saturn's moons, corrective maneuvers were executed. After the successful Saturn mission, scientists decided to conclude the planetary mission of both Voyager 1 and Voyager 2. However, the rockets were sent on another trajectory, venturing beyond the bounds of our solar system, traveling at a staggering 325 million kilowatt-hours annually. In January 1990, the interstellar mission began with Voyager 1 continuing its heavenly journey. During this period, Voyager 1 made significant discoveries, including the discovery of 4 additional moons, Mimas, Enceladus, Tethys, and Rhea, and captured some of the most notable images taken of our solar system. On February 14, 1990, Voyager 1, situated around 6 billion kilometers from the Sun, embarked on a visual journey known as the Family Portrait, capturing stunning images of the solar system's planets. This collection of 60 pictures contributed to Voyager 1's impressive total of 670 photographs taken while it was interacting with Neptune. Voyager 2 also achieved remarkable milestones during its mission. As it approached Neptune, wind speeds exceeding 13,100 mph were recorded, the fastest winds ever observed in our solar system. This accomplishment provided helpful insights into Neptune's distant atmosphere and Triton, its largest moon, with a surface temperature dropping to a frigid 391 degrees F, making it one of the coldest places in our solar system. Additionally, Triton displayed remarkable features including ice volcanoes that erupted nitrogen gas and propelled frozen particles 5 kilometers into its hazy atmosphere. These extraordinary discoveries improved our comprehension of the diversity and complexity of the universe's objects in the outer regions of our solar system. The Voyager missions have delivered groundbreaking and significant results. Voyager 1 and Voyager 2 have revealed that the moons of Saturn and Jupiter, once believed to be heavily scarred and dormant, are in fact geologically active. Voyager 2, in particular, made numerous historic milestones, such as becoming the first spacecraft to pass by Neptune and Uranus, and is the only spacecraft that still possesses this distinction. As a result, NASA employed a variety of strategies to extend the operational lifespan of these daring spacecraft, consisting of shutting down non-essential instruments and energy-saving systems. The mission is expected to conclude in 2030, marking a proud moment with a touch of melancholy for the engineers and researchers who have dedicated themselves to this remarkable endeavor. The design of both Voyager 1 and 2 was a marvel. Constructing these spacecraft as stable, rotating platforms at a rate more than 50 times slower than a clock's hour hand, this design choice diminished visual blur as the spacecraft traversed the vast expanse of space. Even before reaching the outer planets, the spacecraft began transmitting Jupiter-revealing images of its swirling clouds and iconic features, like the Great Red Spot, a massive storm. NASA's audience was captivated by Jupiter at the Jet Propulsion Laboratory. However, the discovery of erupting volcanoes on Jupiter's moon Io garnered the most attention. The instruments on the spacecraft detected surprising signs from Io, which were confirmed by stunning images showing towering volcanic plumes and a surface scarred by one of Io's eruptions. The majority of major volcanoes erupted with a force several times greater than Mount St. Helens, covering an area almost the size of France. As the spacecraft continued their journey, their cameras were eventually switched off to conserve power and memory before they ventured into interstellar space. Notably, the images they captured did not include Mercury or Mars due to various factors. Besides the Voyager missions, NASA has launched other outstanding spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 beat Pioneer 11, becoming the spacecraft closest to the edge of the solar system. Despite the absence of other planets in space probes to observe, Voyager 1 continued its solitary journey for an additional 14 years before entering the interstellar medium on August 25, 2012. The progress of the Voyager missions was made possible through various innovative techniques that used gravity to help maneuver, standing out as particularly brilliant. These maneuvers were critical for propelling the spacecraft to their destinations far away and collecting significant data. The spacecraft relied not only on their own propulsion systems, but also on gravity assists to achieve their goals. Imagine the two intrepid rockets gracefully navigating through our solar system, using the gravitational pull of planets to propel themselves forward. This celestial dance allowed them to conserve fuel and achieve the necessary speeds to explore various locations. Gravity assist maneuvers involve giving the spacecraft a small amount of a planet's energy as it passes by with extreme precision. For example, as Voyager 1 approached Jupiter, the planet's enormous pull accelerated the spacecraft, increasing its speed. Attaining such precision was important. Any deviation from the right angle or speed could have resulted in disaster. Despite the overwhelming challenges, brilliant minds required precision. Behind these missions, successfully carried out, these gravity-aided maneuvers, executed multiple times, launched the spacecraft on an incredible exploration, the grand voyage that was made possible. Voyager was observed through these celestial maneuvers, utilizing gravity assists from Jupiter and Saturn in order to reach Neptune and Uranus. The success of the Voyager missions owes much to these gravity assists as we take into consideration their stupendous journey. Exploratory spacecraft and the wealth of information they have given us eagerly anticipate more information on the Voyager-related investigation. One's brand new anomalies, Voyager 1 and Voyager 2 continue their missions beyond natural boundaries, and the results they produce encompass Jupiter and its moons, Saturn and its moons, Uranus and Neptune. Voyager 1's time-lapse images highlight 10 of Jupiter's rotations in stunning detail, including the discovery of new moons and a small ring. These finds have significantly improved our comprehension of Jupiter's complex system. Voyager 1 also found 4 additional moons of Saturn, Mimas, Enceladus, and Rhea, as well as took exceptional photos of Saturn and its rings, providing new insights into Saturn's intricate system. The spacecraft, through its visit to Uranus and Neptune, provided useful information about their atmospheres and moons, advancing our comprehension of the outermost regions of our solar system. Following the completion of their planetary missions, Voyager 1 and Voyager 2 ventured into interstellar space, gathering data on the interstellar medium. This ongoing investigation continues to deepen our understanding of the universe outside of our solar system. We anticipate more information regarding Voyager 1's latest signals and their potential implications for our understanding of the cosmos. The remarkable journey of the spacecraft remains a source of motivation and awe for scientists and individuals who enjoy space. Their historic achievements continue to push the boundaries of human knowledge and exploration, highlighting the incredible potential of space discovery. The Voyager missions have provided us with a treasure trove of information about our solar system and beyond. The spacecraft's data and iconic images have also carried a golden record, a fascinating artifact designed to share the story of our world with extraterrestrials. The information in this record, selected sounds and images to represent the diversity of life and culture on Earth, includes greetings in 55 languages, music from various cultures, and a selection of natural sounds, such as thunder and whale songs. This message, in a bottle, so to speak, reflects the hope that one day, if intelligent life exists somewhere else, they might discover and understand it, offering a glimpse into humanity's essence. Voyager 1 and Voyager 2, with their scientific instruments, have transformed our comprehension of the universe. Instruments included magnetometers, plasma wave detectors, cosmic ray instruments, and imaging systems, each contributing vital data about space phenomena. For instance, the magnetometers have provided new perspectives on the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing the complex interactions between these planets and their environments. The plasma wave detectors have assisted us in understanding the nature of the solar wind and its relationship with planetary atmospheres and magnetospheres. One of the most remarkable features of the Voyager missions is their ability to measure the heliosphere, a huge bubble of solar particles and magnetic fields that encloses our solar system. As Voyager 1 approached the edge of this boundary, it recognized the abrupt change from the solar wind to the interstellar medium. This data has been significant in shaping our understanding of the heliosphere's structure and its protective function for Earth from cosmic radiation. The spacecraft's observations have provided evidence of a distinct boundary where the solar wind slows down and becomes denser, known as the termination shock. The inner Helios sheath lies beyond this point, a region where the solar wind interacts with the interstellar medium, creating a complex and dynamic environment. Voyager 2's journey has been equally significant. After its successful flybys of Jupiter, Saturn, Uranus, and Neptune, it continued to provide valuable data on the solar system's outermost regions. Uranus was observed by Voyager 2 in a particularly remarkable way, revealing its unique magnetic field, which is tilted substantially in comparison to the planet's rotation axis. This discovery challenged existing models of planetary magnetism and spurred further investigation into the magnetic conditions of other celestial bodies. In addition to their scientific contributions, Voyager's missions have significantly influenced public interest in space exploration. The stunning images of planets far away and their moons, combined with the personal stories of the spacecraft's journeys, have captivated the imagination of people around the world. The images of Saturn's rings, and the detailed views of Jupiter's moons, particularly Io's volcanic activity, have inspired countless individuals and have been featured in educational materials, documentaries, and popular media. These missions have fostered a sense of wonder and curiosity about the universe, highlighting the importance of exploration and the quest for knowledge. The engineering and logistical achievements accomplished by the Voyager missions are also noteworthy. The spacecraft were designed to operate in extreme conditions far from Earth, with temperatures dipping below 220 degrees C. They rely on radioisotope thermoelectric generators that generate power and supply a source of steady energy in spite of the vast distance from the Sun. The engineers who created and constructed these spacecraft faced numerous challenges, including ensuring that the instruments would remain functional for decades and that communication could be maintained over such immense distances. The data returned by the Voyagers has also affected how we perceive the broader cosmic environment. The spacecraft have helped map the distribution of cosmic rays and have provided insights into the density and makeup of interstellar dust. This understanding is only possible with information about the circumstances in the void between stars and prepares for upcoming missions that could investigate additional star systems. As the Voyagers proceed with their journey into interstellar space, their legacy is not only supported by the data they have provided already, but also by the inspiration they offer for future exploration. The missions have paved a path for emerging technologies and philosophies in space science, and have set a precedent for ambitious long-term space missions, exemplifying the potential of human creativity and the value of perseverance in the face of daunting challenges. Looking ahead, the Voyager missions have inspired a new generation of spacecraft and missions. The goal of future investigations is to build upon the Voyager achievements with the aim of exploring further and farther regions of space. These upcoming missions will continue to push the boundaries of our knowledge and will benefit from the foundations laid by the Voyager spacecraft. In conclusion, the Voyager missions represent one of humanity's most significant accomplishments in space exploration. Their contributions to the advancement of our understanding of the solar system and beyond, and their impact on public imagination, highlight the significance of continued investigation and awe. As Voyager 1 and Voyager 2 journey further into the universe, they remain symbols of human ambition and the insatiable thirst for knowledge.